All right, I'm going to try to show you a project I've been working on for about a week. This is a replacement for orgdb. This is called now version 3. I'll go through some history of it. The idea is that I want all of my org files indexed into a database so I can do text search, full text search, semantic search, and I'll show you even image search. So I'm going to go through kind of how I use it. There is a transient menu that you can run. I have it bound to Hyper-V, and we have a bunch of things that, that we can look at here. And the first thing I want to show you is the web interface down here. This is the web interface to the database. This has already indexed one file. I'll tell you why. There's 12 headlines, some links. We have 4 embeddings, and it is the demo that I have already opened and showed you. It tells you about the features. We have semantic search using this mini LM L6v2 with vector search in libsql. We have FTS5 full text search, and we have image search using clip, which is also pretty fantastic, and uses fast API as a front end to the libsql database, and there's a bunch of endpoints down here that get you that Emacs can talk to. Okay, so like I said, the reason there's one there is every time you save a file, you'll see down here that it reindexes it. So as you visit files, edit them, they automatically get indexed and will be available for search. Now that on its own is pretty helpful, but typically we'll want to be able to add files. So here in the examples folder, there are a whole bunch of files about animals. There's some pictures in here. There's a black cat, orange cat, and a dog. There's some other files in here about travel, some linked files. Here's one about graphs. Let's look at that. This has some Python, and I just had some figures in here that that I wanted to be able to work with later. So to index this, I can just press Hyper-V and then press D. I'm just going to index the whole demo folder, and it finds 12 files. I'll say yes. And now at the bottom you can see it's just going through indexing everything. And if we go back to the web page, you'll see now we have 12 files indexed, 9 images, 54 embeddings. It takes the documents and chunks them so that we get pretty fine-grained search later on. Okay, so the first things that you might do, you know, you are working and you want to find something. So I used to do this all by heading, and these are all of the org headings that are in here, and you can just jump to any particular one. Let's do semantic search. This is using Ivy, and I want this lowercase one, and you should see the cursor will jump from here to this headline when I press enter, and it does. So if you keep in mind, you know, if you organize your org files with meaningful headings, then you can quickly jump to them by all kinds of different ways. So I like that. You also can do full text search. So let's say I do Hyper-V and then K. This is dynamic, so as I type in mushroom, it finds, you know, an example of where there is the word mushroom somewhere in a document, and it jumps right to it, and you can see where that is. That's pretty helpful. And then I like semantic search even better. So here I can type fungus, and it will find things that are related to mushrooms. This is a vector search, so not all of these things will be directly related, but it gets sorted like that. I can type kitten, and it finds things about cats. And so you can use semantic search to find things that are related or adjacent to the words when you don't remember exactly what you're looking for. All right, the image one I'm pretty excited about. Here, if I type in the word cat, I see two cats. I can look for a dog. We can type kitten. We can do bar graph, maybe. That finds the first bar graph. Let's see, if I type in fungus, we get a mushroom, that's the top, etc. And maybe let's try contour plot. So it finds, things that are related to that. This was a proof of concept idea. I have lots of figures that I might want to be able to find by being able to describe the figure and see things like that. And then let's see what's in the agenda. So I use this a lot. This one has two items. Everything that's marked to do will be in here. And what is this one? First heading, this is a to-do item in the examples. That can be helpful. And this one is the demo that's here. And let me just add a couple of to-do items. I want the snippets to be a little bit more bigger. And let me just make that due today. I might work on it later today. And now this should be already shown there. You can see we have the deadline here. And if I change this, let's make this overdue. Then it shows a different color. So it gets sorted by due date, and if it's overdue, it's red, and if it's green, then it's it's in the future to be done. So I like this because I have to-do items spread all over my org database like that. And I didn't say it, but let me come back up here. I'm using a temporary database here, so I don't show you all of my personal to-do items, but I have about 8,000 org files spread over the last 15 years of using it. That leads to about 100,000 embeddings, 105,000 headings, about 17,000 images, and that is about an 11 gigabyte database spread over the three different full-text, semantic, and image databases, and it still performs extremely well. I'm super pleased with how well this works. All right, so that's the agenda. One of the reasons I wanted this is for integration with large language models and GPTel in particular, where you can now imagine you want to use your own notes as context to generate something. And I'll note this is your own notes, and if you use a cloud LLM, it's going to send information from your notes out to the LLM, and that could include private information. It could include personal stuff. So this is not enabled by default, but you can turn it on. And so we just do it like this. We'll register these tools, and now let's look at this. If I say tell me about travel, then I'll go to the GPTel menu, and then I'm going to select tools, and I want the orgdb tools, so I press O, and then I'm going to toggle them all on for that. And then we'll say insert response, and now it should be looking there. It's going to do two searches on my own files. Let's see what it finds. It finds the travel planning file, so there's a dedicated examples travel.org, and then similarly this is probably going to find quite a few things, and I have it set to tell me when it calls tools, just so I know. Let me shrink these back down. They're usually hidden just in a single line, and here's what it finds. It tells me where it found it, some comprehensive plans and accommodations, etc. And so this is a way you can leverage your previous notes, your previous research for finding information and incorporating it into a response. And it sort of happens automatically. You don't have to know where those things are. as long as it's in your database, it will be able to use it. So I think that's pretty fantastic. I will talk about a limitation. There is in principle a way to have this index linked external files. So if you link a PDF or a docx or a PowerPoint.x, then it will index those and those become searchable. It's currently disabled because, or not on by default, because I have, again, 8,000 files, and it turned out to be about 8,000 PDFs and other things linked for a reason I don't totally understand. But it caused a lot of performance issues, and so I just disabled that feature for now. It may be fixed. I fixed a lot of performance issues since then, and when I re-implement it, it will go in a separate database, so no database gets particularly large. But in the end, I didn't think it was a feature I needed, like, mission critically, because well, so far it just hasn't been super necessary. Okay, let me tell you about how this project came about. So this project is actually completely developed with Claude Code. I don't think I wrote any of the code myself. I only looked at this as a starter. So I used GPTel to help me look at what I had in the original OrgDB, and that was a pure eLisp interface to SQLite. And I told it to, with these links, it would review what was in the previous capability. I said I want a fast API server with libsql for all of these full semantic search. I think we didn't end up getting audio. I don't have a lot of audio in there. This was just a proof of concept, and audio is pretty slow. But then I told it to review those files and then come up with a set of features, and it gave me this. All of this text that said, what the previous version was capable of and did. And then from here, I sent this to, I think I added some new features. Looks like I wrote this. And then I gave this document to Claude Code and told it to go. And it started going. Usually you say, make a detailed plan, and then it creates a 10-step plan, and then you go through the steps, and so that's how it went. Now, this is the 5th iteration of this project. I started in 2017, making the first OrgDB, and then in 2024 transitioned away from an older Emacs SQL library to the native SQLite library. And I was mostly happy with that, but it didn't have the vector search that I was aiming for. So last month, I tried to make a ChromaDB version. Actually, there was a previous ChromaDB version I'd worked on over the summer that I left out here. But I spent a day on that and then learned it doesn't work across multiple machines. I sync all my machines through Dropbox, and I have a home office and a work office and a laptop, and they all have to work. So I abandoned that. And then I spent about 3 days trying to get libsql to work. I've done a lot with that. It's a SQLite fork that directly supports vector search. And that worked pretty well. And then I decided to try to implement as many of the features as I could in OrgDB version 3. So this took about 8 days. It's been about 8 days since I started it. And it's resulted in like 17,000 lines of code that is split between eLisp, the server, some tests and documentation, which is pretty remarkable. I could not have written this in a week by hand. The previous versions took months and months to work out. This what I just showed you didn't exist 8 days ago, and today is this video. So it's been about 7 calendar days. The first commit October 11th, and the latest commit sometime this morning. And it's been mostly active. I think there's been about 100 commits, so that gives you an idea of like how much iteration and churn was involved. About 15 to 17 commits a day. Here's sort of the breakdown. The vast majority of it happened in the first 2 days. And then after that was really just polishing. So in 2 days, I had a working prototype. And then the rest of this was really figuring out, performance issues, UI issues, things of that sort. And here we are today. I've been using this for a couple of days now, and it seems pretty stable. Maybe half of it is new features. Quite a bit is bug fixes and refactoring and performance improvements. This is a report generated by Claude. I didn't write this part. I just asked Claude Code to tell me, what happened, and it just gave me all of this output. So built in about 7 days. Most of the work done in the first 2 days, and yesterday was busy. I didn't do anything but tested in various places. And this is all of the work that came. It says this is 10 to 20 times the typical pace. I don't know what that means. I can tell you the first version took, probably 6 months to get, fully working while I figured out how to interact with SQLite, how to design the databases, and here I didn't do any of that. I just told it what I wanted. So let's see. I don't know if it's worth looking in here. It makes a regular Python package that has pyproject.toml. It has all the dependencies that are required. It sets up, it set up some tests, all kinds of other stuff like that. And then on the eLisp side, it created all of these files, and they work as I've demonstrated them here. And that sort of brings me to the end of the demo. I'm pretty excited about it. It is a huge improvement over the previous DB system that I had that didn't include vector search and wasn't easy to integrate. And I'll go ahead and mark that done. And then we'll see that it doesn't show up in here anymore, but that one does. All right, it is available on GitHub. The link will be in the video description, and you can try it out. You have to install some Python packages and install some eLisp packages, and then hopefully it will work as advertised and demonstrated here. All right, thanks for listening.